Hello everyone, my name is Ilya Burnikov and I'm a pre-sale engineer in IT Global. In the previous video, we started talking about collaborative FlexPod architecture designed by NetApp and Cisco. We also showed the NetApp AFF 700 SAN, reviewed its hardware components, and ran it at our data space in Moscow. In this video, we'll talk about the second component of FlexPod, its server and network hardware by Cisco. As you remember, Cisco and NetApp Alliance generally aims at delivering pre-built and pre-tested hardware combinations to operate required software. In our case, it is VMware. IT Global platform is built upon the FlexPod data center architecture and based on the Cisco UCS blade servers, the Cisco Nexus Ethernet switches, and the NetApp AFF SAN. This Cisco solution, Unified Computing System, UCS, is very different from rival ones. Let me tell you more about it. The main difference is the network architecture design, which is noticeable at the time of Cisco UCS rack mounting. The rivals offer usually such an approach to blade solutions. You have a big blade chassis, then you install some switches on it, FC, Ethernet, the separate group of aggregation switches, FC fabrics, 1040 GB Ethernet, and separate management networks. Such a solution implies a lot of links, as well as the huge number of management points which should be maintained, upgraded, and configured separately. Cisco offers another approach based on the unified fabric. Firstly, the switches are not installed on the chassis. The entire switching is performed with two core Cisco UCS fabric interconnects. In our case of the latest 6454 series, they are the brain and the heart of the system. Secondly, the pair of fabric interconnects is the single management point for the whole infrastructure. But first things first, FI6454 is Nexus in hardware, but it has its own software. It includes 48 10/25 GB Internet ports. The first 8 can be reconfigured as 32 GB fiber channel if you are still a fan of traditional SAN storage area networks. The other ports are used to connect the blade chassis, while the last 6 100 GB interfaces to uplink. The enclosures of the UCS 5108 blade chassis are unified, so its connection to fabric interconnect is not a problem. The current enclosures are connected via 10 GB Ethernet links, and new ones are planned to be 25 GB. One pair of fabric interconnects supports up to 20 chassis. Mikhail Novoselov, our senior engineer, will help us to review them. Hello everyone! The Cisco UCS portfolio includes only 5108 blade chassis that has not been changed since 2008. It takes 6 units and allows installing 8 B200M5 half-width blade servers. We'll talk about them further in detail. There are 4 times 2.5 kilowatt power units with N+N redundancy and 8 fans providing front-to-back cooling. The back chassis surface is ventilated, which provides the best-in-class heat transfer performance. 2 fabric extenders, or FXs, are also installed on the chassis. We have IOM 2408 with 8 ports, 25 GB each. Again, they are not switches, but a remote line card in relation to fabric interconnect. It means that all 20 chassis with up to 160 servers are connected into a single switching fabric. It ensures minimum latency. A physical server in one enclosure can ping a server on the other side of the rack in another enclosure with one hop. Fabric extender has been mentioned to be the single management point for the entire infrastructure using Cisco UCS Manager. The servers, the chassis, and fabric extenders are a single managed entity. We don't think about configuring each physical server separately. The firmware, BIOS, RAID parameters, the number and types of network interfaces, MAC and IP addresses, VLANs, boot LANs which should boot the host. All this stuff is actually packaged in one XML file with graphical view based on UCS Manager and then connected to a server farm. It allows us to get started with new resources as soon as possible. We have received 24 servers, and now we should install ESXi on them. Only one time we will create a server profile, connect it to all needed servers, and then get a pre-designed resource set. Actually, scaling will be much easier in future. For example, when we add an enclosure, UCS Manager can just apply a selected server profile to it by default. It will receive all variable parameters from the available pools, MAC and IP addresses. Let's move on to the Blade servers. Last time we received B200M5 with the latest Intel Xeon Gold scalable CPUs of the second generation. A half-width form factor allows installing up to 8 such servers on one 6-unit chassis. Our infrastructure uses Intel Xeon Gold 6248R, the most interesting CPUs for the 2-socket servers. Each CPU has 24 cores with high base processor speed, 3 GHz. There are in total 48 cores for the Blade, or 384 cores for the enclosure. We also have 24 RAM modules up to 1 TB for a 2933 MHz CPU. We use FlexFlash module as an ESXi hypervisor, which includes two 32 GB SD cards supporting the mirror. For Microsoft solutions, we can use a module with two M2 SATA SSDs. In front, we can install two 2.5-inch hot swap drives, be it a traditional SAS HD SSD or an NVMe. As a network card, we use Cisco VIC, Cisco Virtual Interface Card, which provides us with 40 GB of aggregated bandwidth for a host, 20 GB power channel towards A fabric, as well as towards B fabric. Cisco company is proud of their Cisco VIC, a unique virtual network interface card that manages, accelerates and unifies the fabric and computing resources. You just create as many virtual network interface cards and HBAs as you need. At the OS level, they will be seen as separate physical interfaces. A separate VNIC can be even added directly to a virtual machine. It's time to move from theory to practice. Now I'll show you how quickly and easy 24 servers can be started with Cisco UCS Manager. When new devices are detected, I/O modules are automatically upgraded to Cisco UCS Manager version. Now, both I/O modules are rebooting. That's why they and chassis are not accessible. As soon as they are up, the chassis will change its status. The modules have been configured and chassis management has been restored. The Blade servers are being discovered. The servers have been discovered, yet they are unassociated. Let's check their readiness before configuring. Everything is ready, so we can move to configuring. To begin with, we should create a new resource pool and add it to our servers. Then we describe the template of logical servers configuration. We do it through creating service profile template, where we specify previously configured pools and policies. We create 24 service profiles from the template. Each profile is unique. All identifiers, for example MAC addresses of network interfaces, are assigned to a particular profile. The created profiles are associated with the physical servers from the previously specified resource pool. From the physical server, we can see which profile was assigned to it. We should wait until the association will be completed. The servers will be updated for specified firmware and apply our configuration. We can view the components updating in the corresponding tab. Activation is running in parallel at all servers simultaneously. The association with the server profile is completed. All alerts have gone, so we can use a KVM console to install the operating system. Here were Ilya Bernikov and Mikhail Neveselov. See you soon!